We have another example. Let's check what we're supposed to find in this problem. So I have to find, okay, and we have to find P1. We're supposed to find IR2, and we're supposed to find IR3. Okay, this arrow means that I have to find this current, and I'm supposed to find P3. Okay, so first of all, in order to make this problem look a little bit simpler, for those of you who have difficulties to see what's going on over here, let's redraw the circuit. Okay, so we have voltage source. Okay, let's call this VS, and it has 18 volts. Okay, and we have power. Okay, power source. Okay, positive terminal of the voltage source is connected to resistor R1, is also connected to resistor R2, and is also connected to resistor R3, because this is like voltage source over here connected between the ground and this point. Okay, so we have a voltage source connected to the resistor R1. Okay, and this is my ground, by the way. And we have resistor R2 over here. Okay, resistor 2 is connected to the positive terminal and is connected to the ground, and resistor R3 is connected to positive terminal of my voltage source and ground. So it makes this circuit parallel. So this is R1, R2, and this is R3. Okay, we have to find the power P1. Okay, let's take a look what we have given. We have given voltages. Okay, I can say one voltage. You have to keep in mind that voltage source is equal to VR1. This is also equal to VR2. This is also equal to VR3, because this is parallel circuit. In parallel circuit, okay, the voltage across each component is equal to the voltage source, like we have in this case. And this is equal 18 volts. Okay, you're supposed to remember the formula for power, because we have voltage and we have resistance. So we can use this form of the power formula. Power P1 is equal VR1 to the second power over R1. Why I'm using this formula? Because I have voltage across this resistor and I have resistance of this resistor. That's why I'm using this form. I don't have to find, let's say, a current in this case, because it's not needed. Okay, I can find the power without the finding the current in this resistor. So I have VR1 is equal 18 volts to the second power over R1, which is equal 5.2 kilo ohms. So this is equal 18 square divided by 5.2 exponent 3. This is equal 62.3 milliwatts. Okay, power is measured in watts. 62.3 milliwatts. Okay, so we found power P1, I mean power which is going to occur at this resistor. Next, we're supposed to find the current IR2. Okay, so Ohm's law, IR2 is equal VR2, because VR2 is given, okay, this is 18 volts, over the resistance of resistor R2, which is equal 3.9 kilo ohms. Okay, I'm supposed to write the formula first. Okay, so but keep in mind that this is nothing else, just R2. So VR2 is equal 18 volts over 3.9 kilo ohms. Okay, so this is equal 18 divided by 3.9 exponent 3. This is equal 4.61 milliamps. 4.61 milliamps. Okay, so this is the current IR2. Next, I'm supposed to find current IR3. Okay, so IR3 I'm going to find the same way how I found IR2, because voltage source is given and resistance of resistor R3 is given. That's why I'm going to write that IR3 is equal VR3 over R3. VR3 is equal 18 volts over R3, which is equal 4.7 kilo ohms. Okay, and this is equal 18 divided by 4.7 exponent 3 is equal 3.83 milliamps. 3.83 milliamps. Okay, so this is the current IR3. Next, I'm supposed to find P3. Now let me give you advice. Okay, I have to find this power. Even if we found the current which goes through this resistor, I'm going to use the formula which we used before. Why? Just in case, if you made mistake with calculating the current, okay, let's say this answer is wrong, and you are going to use the formula for power with this current, so you are going to have two answers wrong. Okay, two answers wrong because the wrong current is going to give you wrong power. So if this is possible, okay, if this is possible to use the quantities which were given at the beginning to find whatever is missing, use first those which were given at in the problem. Okay, and if you have no choice, you're supposed to use the one which you calculated. But in this case, I have voltage given, I have resistance given, so I can use these two quantities to find the power. So I have P3 is equal VR3 to the second power over the resistance R3. So VR3 is equal 18 volts to the second power over R3, which is equal 4.7 kilo ohms. This is equal, now we have 18 square divided by 4.7 exponent 3. This is equal 68.93 milliwatts. Okay, so this is 68.93 milliwatts. Okay, we found the power P1, we found IR2, we found IR3, we found P3, so we can say that problem is solved.